Hello everyone, welcome back to my channel. My name is Manthan Sharma from MCA 3rd year IAPS GFV. In today's video, we are going to explore one of the most important technologies in history of computer graphics, the Color CRT model, which powered the early monitors, television, and multimedia system for decades. So let's understand how they work and why they were so revolutionary. What is a CRT? A CRT or cathode ray tube is basically a vacuum tube equipped with electron guns that fire a beam onto a phosphorus coated screen. When the electron strikes the screen, they generate light, creating images. So from the early 1950s to the 2000s, CRT was the dominant display technology. They provided vibrant colors, fast response time, and laid the foundation for early computer graphics and multimedia. So the color CRT system are built entirely on the RGB color module, red, green, and blue. These are the primary additive colors. When these three phosphors on the screen glows with different intensities, they create every color we see. So this RGB principle is still used today in modern displays like LED, LCDs, and OLEDs. So how a color CRT works? Inside the tube there is three electron guns, each one of red, green, and blue. This gun shoot electron towards the screen, but to make sure each beam only hits its matching color phosphor, a shadow mask with tiny holes is placed behind the screen. Next, the electromagnetic deflection coil rapidly moves the beams left to right, top to bottom, to scan the entire screen. So the phosphorus, so that this phosphorus screen can glow at the precise point where the beam strikes. Okay. So the color generation process is like it is actually a trade of three phosphorus dots, one red, one green, and one blue. When the electron beam hits these three dots, they glow through a process called phosphorescence. By controlling the intensity of each electron beam, millions of color combination can be produced. So CRT's refresh rate image is between 50 to 120 times per second. The phosphors continue glow briefly after being hit, and together with the higher refresh rate, it gives us smooth and flicker-free visuals. So now let's see the CRT model by its diagram. So here we have electron gun and a deflection system. As we have learned previously, that three electron guns are there in a module. So the electron guns, each one of red and green and blue, this gun shoot electrons towards the screen, but to make sure beam only hits its matching for color phosphor, we apply a shadow mask with tiny holes placed behind the screen. Next, the electromagnetic deflection plates are X and Y, which continuously moves up and down and left to right, so that the entire screen can glow after the electron strikes the beam. The electron strikes the screen. A color CRT contains five key components. First, electron gun. This generates and fires the red, green, and blue electron beams. The second is deflection yoke. It is an electromagnetic coil that steers the beam across the screen. Third is shadow mask. This perforated metal sheet that ensures each beam strikes the correct phosphorus dot that we have previously studied in our previous slides. The phosphorus screen is the front surface of the core, which is coated with the RGB phosphor traits. And fifth is a glass envelope, which is a thick volume sealed glass tube that holds everything together. So all these components works in perfect synchronization to create stable and a vibrant image. So now let's move on to the advantage and limitation of CRT module. CRT has several advantages that made them popular for decades, like superior color accuracy, wide viewing angles, fast response time, and no response times means no motion blur, and also bright and vivid images. But they also had some limitations, which were they had a bulky design. They were highly power consum. They had very high power consumption, and also low level radiation emissions, and also possible flicker at low refresh rates. So because of this issue, CRT was eventually replaced by modern flat panels. Now let's move to the CRT application in computer graphics. So before LCD and LED took over, CRTs were used everywhere. They powered early computer monitors, televisions, professional graphic workstations, and even video station editing studios. High-end CRT were specially priced for the accurate and consistent color outputs, which made them essential for designing and animations. So thank you everyone for watching my video. I hope you have a very clear understanding of the color CRT model and its role to the evolution of the computer graphics. If you found this video helpful, make sure to like, comment, and subscribe so I get the motivation to make some more videos which will be helpful to you. And if you have any questions, feel free to drop them in the comment section below. Thank you so much.